And in the next few minutes, I'll be sharing some of the cool features that we have in TBC in terms of point cloud processing functions. Okay? This session will be focused on all the point cloud processing. Tomorrow's session that I'm covering on TBC will be going into details of the other kinds of functions that we have in TBC, because it is a very big package with a lot of different functionality. Okay? So today I'm just going to talk about the point cloud processing. Now the things that I'll be covering, the key things that I'll be talking about. First of all, will be introduction to TBC, and then we'll be looking at scan inspections. Okay, this is the kind of inspections that we can do back in the office. And point cloud classification, we have done a lot of development for point cloud classification in the recent months to develop the AI classification of point cloud. Okay? And lastly, will be some of the feature extraction functionality that we have in TBC. So introduction, TBC is our all-in-one software, our field-to-finish software that we have. It's able to take in all the different kinds of hardware data all into TBC, whether it's scanning data, total station data, or GPS data. There's a lot of different workflows that we can do inside, ranging from drafting to preparing surfaces, point cloud processing, and even a lot of vertical applications such as aerial photogrammetry, mobile memory processing, and monitoring. Okay? I won't go into detail with those particular vertical applications for this session, but you can see here that we can take in all the different kinds of data, and there's a lot of different workflows that you can run through within the software. Okay? We can also export out to different kinds of software if you want to continue your data processing in a different software package that you might be familiar with or that you're using. We can also continue the data processing. So, for example, in the workflow that we're talking about today, we can do our scan data processing in TBC, and then we export the data out into the SketchUp environment for modeling of the point cloud. So the three advanced workflows that we talk about is inspections, point cloud processing, as well as the verticals. We will be covering verticals in this session. Just quickly cover the scan inspections. So scan inspections is similar to what we saw just now in the demonstration in terms of the comparison between point cloud and the model. So the three ways we can do it is in TBC is a scan-to-scan comparison, which means that we can compare the differences between two different point clouds, or point clouds that you have captured at two different points in time. So for example, maybe a monitoring kind of application, or an application where you want to see what is the changes between one scan and one scan. Okay? So we have that function of scan-to-scan comparison, and we can also do scan-to-model instruction. So nowadays we have a lot of design models, we have design surfaces that are all brought, we have available for projects. And this is when we can make use of those models to compare with a point cloud to see if the construction project or the kind of work that we carried out is in alignment with the design model or not. Okay. So these are some examples as well. For example, you have a design model of a tunnel, and you have scan data. You can do inspection, scan inspection, comparing the two to see what is the deviation. And we have a color scale bar that will show you the amount or the deviations according to the tolerance that you set. So if you only need to care about very big values, major differences, you can always set the tolerance as a higher value. So once you do the inspection, you can generate out a report, and you can also select specific points within the inspection area that you want to get the actual deviation values. If you can see in the report, each point that you select in the inspection area will give you the coordinates, XYZ value, as well as the deviation value to the exact millimeter. Okay? So that's what we can generate in terms of the inspection report. Point cloud classification is one of my favorite functions that we have in TBC. Automatically classify point clouds into different layers for you to process. Okay? So you can see these are currently the fixed layers that we have available in TBC, which means that you can load in any kind of point cloud into TBC, and then you can run this classification, and it will immediately detect based on the AI deep learning process that has been trained to classify it into these different layers. Okay, so this is what we have standard at the moment in TBC. You can see when you run a point cloud through a classification process, the trees here are classified into one layer called the high vegetation. The buildings goes into a layer called buildings in blue, and then the ground is brown, and so on and so forth for the different layers. So this allows you to work a lot easier with your point cloud data. We also have an indoor classification function. So a few of these things can be classified, like the usual ground, floor, ceiling. This can be classified for indoor application if you have point cloud data and you want to classify it. So we have done a lot of development in training TBC and its AI algorithms to be able to detect more and more different kinds of layers or features, right? So for example, we added fans and low vegetation, new features along the way with each release of TBC. Okay? So that's why it's important to stay up to date with this kind of software where we have a lot of constant development in the software. So if you are on like a subscription or if you have a maintenance, you can constantly update it and get the latest features and functionalities of our software. So some additional examples of how we do the classification. You can see that noise, things like cars and people in your scan environment are classified into a layer that we call, I believe, is like noise or some others layer. So this allows you to clean up your data very easily. One challenge we always have with point cloud data is we capture data of everything that is there when we do the scanning. Right? But a lot of time, we don't need a lot of that data. And a lot of that data is actually noise. For example, we don't want any humans in our point cloud data. Okay? There's never a time that we want humans within our point cloud data. And the ability to classify them into a layer, or even like vehicles on the road, classifying them into one layer allows us to easily switch off that layer, so we don't have to spend time manually cleaning up all those points. Okay? So these are some examples. Noise layers for data like this in the area that we scan like that. We can classify it, and you can see vehicles, people, humans all classified into a noise layer that we can just switch off. Medium vegetation. So now we do a differentiation between high vegetation like trees as well as bushes or shrubs for medium vegetation, and you can see the lampposts are classified in red. So this is an example. When we do our scans of our area, the point cloud data in this case colorized based on the scan location is just a mix of points. Right? Sometimes it's very hard to make sense out of a whole bunch of points like this. But once you run the classification function, immediately it helps put the data into different layers and allows you to see and identify the different features of the point cloud. It's a lot easier to visualize your data. It's a lot easier to work with your data as well. You can zoom in and you can see like power lines and poles and the noise area. And what if you want to focus on a particular layer or a particular classification layer? You can just take away, for example, like the noise layer of the cars, and just leave your power lines and your ground layer there for you to visualize and to work, or do whatever further processing you want to do. Okay. In our recent release of TBC, we had a new function which I think is really interesting, and that is the ability to train your own custom deep learning models. So what does that mean is, if you have a specific kind of object that you want to classify every time from every point cloud that you have, you can train the point cloud or train TBC to detect that particular feature by giving it a bunch of training data sets and validation data sets for it to learn through its AI algorithms. And you can generate a custom 3D classification model that you can apply to any point cloud, and it will be able to detect for you that particular object. So for example, here could be an electrical box, fire hydrant, some particular unique thing in your particular country or region that you want to train your TBC to be able to detect from the point cloud, you can do that and you can train your TBC to do it. And this is designed to be a function that you don't need to be a programmer or AI expert to know how to do this. You just need to use TBC, and there's some simple steps that you can use to configure it and train it to be able to have this custom deep learning model. Okay? So this is some example of how it looks like when you train your model. Okay? You can select a point to check on the size of the point cloud density that is required to train your point cloud. Okay? We call it the voxel size. I will explain that a little bit in the later slides. So previously, if there was a feature, for example, this kind of utility markers that you wanted to be able to classify, you would have to do everything manually, or you would have to send a request to the TBC team to try and train up, to develop a model that can help you do the extraction. But now, with this latest release, the power to train the models is in your hands. You just need to train the model, give a few data sets for it to learn, and you'll be able to automatically classify it yourself or train it up yourself. So this is an example of how it looks like. Okay? You can build your own classification and it can solve your specific kind of problems in point cloud processing. So this can be used even for UAV data, not only for scan data. Whatever point cloud data that you have, you can train the software with it. So like I mentioned, this is meant to be a very simple flow. There's just a few different configurations that you need to figure out, and you need to key in, and then you can run the training, and based on the graphs, you can see whether how well the training has been completed. And once it reaches the desired accuracy of the training, you can stop it and create the model, the custom model as it is. So these are some examples that I'm going to share on how it's used to train custom model. Okay? So for this particular application was for customer we had called Joe Era, and they actually trained the software to detect the sidewalk into a different layer by itself. So what happens is you throw in the point cloud, and now they can classify the sidewalk, the low grass, and the electrical boxes all into separate layers, custom to their country's kind of setup. For example, for electrical boxes, it might not be the same in every country. But in this case, they are training to be able to detect these three things based on their own data and their own trained model. Okay? Another application that was done by the team in Dubai is training the software to detect different kinds of trees. So from here we have the gum tree and the dead palm tree. They train the software to detect the different trees and to put them into different layers. Okay. Another application is insulators for the electrical power towers. So even such things like this, extensions from the electrical tower, we can classify them if your training data is good. Using a local data set, this is something that I trained myself when I was testing out the software. What happens is that I had a data set of Trimble in Singapore, and so far there wasn't a way to clean up the data within the tunnel very easily. But using the data set I had, I trained the software to be able to detect the tunnel wall as one layer and to extract out the real track point cloud. So this can be very useful if you're using, for example, a geometry survey of a tunnel. You can now scan it and you can classify it automatically so that it immediately extracts out the tunnel wall for you to do your geometry checks, as well as the real data for you to get the point cloud data of the coordinates of the track as well. So this can save you a lot of time. The training of the TBC point cloud custom model, it's a one-time effort. Okay? Once you train up the custom deep learning model, you can use it for all other data sets and you will not need to train it again. Okay? So it's a one-time effort just to get the training up. So how the software works is it actually samples down the points into samples your point cloud data into 25,000 points per sample, and from there it kind of tries to detect the different features that you have trained based on the samples that you have provided to the software. So that way you won't be working with a huge big data set of point cloud, but it samples it down and then it tries to detect the different features within the point cloud. Okay? So based on the voxel size, like I mentioned earlier, the voxel size affects the size of the feature that you want to train the software to extract. So for example, in this case, if you want to extract something like the utility markers, you will need to use a smaller voxel size because the sample of 25,000 points here will be sufficient for you to see the feature. Whereas in a bigger 10 cm voxel size or bigger sampling size, right, you still have 25,000 points here, but it covers a much bigger area because the size is 10 cm. So for smaller features such as these utility markers, it can be very difficult to detect. So this becomes, this makes you have to make a decision in terms of what kind of size you want to use when you are training the software. And of course this one might require a little bit of testing for you to try different sizes for it to train. So similarly, if you are training detection of a building, for example, you cannot use too small a voxel size like 10 cm because you won't be able to capture enough of the features of that particular feature you want to extract. So this is a bit more of the technical portion into actual training of the software. You can always go through more detail if you want to find out how to do it. But basically, for the training, you will need to prepare two different data sets. Okay? The first data set will be a training data set where you first have to manually classify it by yourself first, manually as an example data set, a training data set, as well as a validation data set where the software will train and validate how well it has been trained. So that way, this data set can be used to develop the recognition of the software. So lastly, it will be the testing data set, which is ideally a third data set where you can test out your completed custom model and you can run it to see whether how well it performs based on your completed model. Okay? Okay, so that is covering the custom point cloud learning. Let me know if you want to go into more detail, I can share with you. So another thing I want to share with you is the advanced point cloud filtering function that we have in TBC. So firstly, we have a number of ways that we can filter point cloud. One of it is based on an alignment. So for example, if you have a road data set from mobile mapping data and you want to filter out the things around it, and you only want to capture the road data, you can immediately run filtering based on the alignment or based on the polyline along the road, and it will filter out based on the offset. Another thing we can do is, for example, like a tunnel data set. If you have the design alignment, you can run the classification based on the filtering based on the radius around the design alignment. So that way, you can immediately clean up the data around so that you don't have any extra data that you do not want. Okay, so that's one of the ways of filtering that we have. A new feature we have for this advanced point cloud filtering is what we call a background filter. Okay, I'll give a mere example, but basically you remove away those like low grass so that you can just leave the background data below, and this is very useful when you create surface models from your point cloud data. So this is an example point cloud that I have. You can see it's actually a hilly area with grass area and road. So the first step I did was to run the classification on the data. So just automatic classification, and from there I can isolate the ground layer to work with it. And then if you look at an angle of the ground layer, you can see that there's a lot of grass. And if we create a surface based on this data set, your mesh surface is going to be all over the place. Right? It's not going to be a good, clear representation of the actual surface. After we run this advanced point cloud filtering, we can choose the cell size some minor settings on the filtering, and what it generates out is a very clean surface based on the ground surface exactly. So with this point cloud, it will be much easier and much better for you to generate out a surface model as design model for your surface based on this filtering. Okay, so if you have any kind of workflow where you are using laser scan data and you want to create accurate surface models of the ground, this will be a super good function or feature for filtering your point cloud data. Okay, feature extraction. We've talked a lot about classification and filtering. Now we have something called feature extraction, which is basically automatically creating geometry data from your point cloud data. Okay? As of now, when you do point cloud classification, the different features are in different layers, but they are all still point clouds. This is some of the functions we have to convert specific point clouds into geometric features. For example, trees. So in this example here, what we have done is it can automatically detect trees, and it can automatically detect the spread of the tree, the girth of the tree trunk, as well as the height of the tree. So you can see from this example, the circle is indicating the spread of the tree. The cross below is showing the base position coordinate of the tree, and the small little circle over here is showing the size of the trunk of the tree. And then the straight line all the way to the top there is showing the height of the tree. So just from the point cloud data of the tree, is able to extract this information and create a tree symbol from the point cloud data. So what are the features that we can extract now in terms of geometry extraction for in TBC? Here are the different line features as well as the point features that we can extract. So for line features, things like the overhead lines, we don't have that here in Singapore, but in a lot of the other countries we have that. Curb and gutter lines is something very interesting where you detect the curb of the road as well as the little gutter, and you will draw cat lines automatically tracing based on the point cloud data. Lane lines, you can see such as the lane lines, whether it's dashed lines or solid lines, they can do the automatic extraction based on the intensity data. So that means that the intensity differences between the lane lines as well as the surface of the road, the white marking and the black surface of the road, you are able to detect the difference in intensity, and then you can generate the lines automatically. Okay? Point features very interesting. I mentioned just now about the tree extraction. Tree extraction from point cloud. And because you can extract out the spread, height, and girth of the tree, we can also create a scaled symbol of the tree in our software. Which means that you can see here the different sizes of the tree symbol. Okay? So if your spread is bigger, you will have a bigger tree symbol. And if it's a very small tree, a small spread, it will generate a smaller symbol. So from here, from your geometric attributes of the tree, you will see the differences in the size of the tree. Okay? You can also extract holes, size, and manholes. This is a fast-forwarded video on how the tree extraction will actually work. So in a TBC environment, we can go to the extract point features, select trees, and then extract tree. So there's a way to do it automatically as well as manually. So in this case, if automatic is selected, you can see once you run it, it will immediately detect for all the trees in the point cloud region. Okay? From there you can see each individual tree, its location, as well as the sizes and all the attributes. And this is a very simple tool that allows you to do a very quick QA/QC check of the point cloud data of the extraction to make sure that it didn't extract anything wrongly. If there is something that has been extracted wrongly, you can always just click ignore, and you will not create a geometry, a symbol there anymore. I will skip through some of these other extractions because they're pretty much similar. But something pretty new that we have added is the ability to detect manholes as well. So extracting manholes, I think we have that everywhere. Also based on the point cloud data, we can extract the the symbol, the position of the manhole as well as the diameter of the manhole, and that will create a symbol over each of these positions. Okay, I'll skip through these overhead lines. Geometry extraction, if you have a custom, for example, if you want to do road traffic marking on the floor, you can create the arrow shape or whatever turning shape or whatever symbol we have on the ground, and we can do extraction even for like zebra crossings or this kind of specific symbols on the road. Okay, so this is an example for road symbol. I'll just skip through this as well. Okay, so feature extraction, lane line features I already mentioned just now, detecting single line, double lines or dash lines automatically for the point cloud data and the intensity values. So if you want to create, for example, traffic marking plans from your scan data, we have a lot of tools in place for that. Whether it's the lane lines or the symbols, you can do all that creation in TBC. Okay, lamp post is quite interesting for pole and sign because we can also extract out the inclination of the pole. For certain regions where the asset management is important, when you have laser scan data or like a mobile mapping data of certain roadways, they want to know if the poles are straight or are they tilted, because there could be a risk of the lamp post dropping if it's too much of an angle. So this is one of the interesting attribute information that we can extract out automatically from the poles as well, the inclination of the pole. Stock power extraction, I think stock power is a very common stock power volume calculation is a very common requirement for a lot of different projects and applications. So we have added in a new AI feature where it automatically detects your stock power and calculates the volume for you. And this can be done for multiple stock powers from your point cloud data, and you can very quickly just click one point on each of the stock powers and just it will generate out a whole table of the volume of all the stock powers. So this thing will really save you a lot of time, especially if you need to do a lot of stock power volume calculation. So whether you're using a scanner to scan the data or you're using UAV, photogrammetry or LiDAR for the data collection, it doesn't matter, we can use the point cloud and calculate the stock power volume. Okay, that is what I had to share in terms of features for TBC in terms of the point cloud processing. We have a lot of TBC resources available, and one thing that we have is a 30-day trial available for everyone to try. So if you're interested in any of these functionalities, you can check out our trimble.com/TBC, search for TBC on Google, it should come out as well, and you can download a free 30-day trial. There's some steps to create a user account or Trimble ID with your email, and then from there you can unlock the 30 days of testing. Okay. If you want more details on this, please let me know. I'm happy to help you with that. We also have a lot of resources available to teach you on how to use TBC, whether it's webinars, resources. We have tutorials for each different kinds of workflows, so we can teach you step by step and how to do all this functionality. Okay, it's not something that you just buy the software after that you don't know how to use it. Okay, we have sufficient resources for you to check and to learn based on the specific workflows that you need to do. Okay, thank you very much. That's all I have for my session. I think right now I can